In this video, we're going to continue topic 10.10, and we're going to look at example 2a. So in this example, we're going to try to figure out when does an alternating series provide a sum to a given accuracy. So we're supposed to determine the number of terms required to approximate the sum of the given convergent series with an error of less than 0.001. The first thing we really should do is make sure that we actually have an alternating series here that's convergent. So step one in determining that is the limit as n approaches infinity of the absolute value of that series, 1 over n squared. So that definitely equals 0, and our first thing is satisfied. Then we just have to make sure our terms are decreasing. So 1 over 1, when I put a 2 in, I would get 1 over 4. When I put a 3 in, I get 1 over 9. So I definitely am decreasing. So this is definitely a convergent, I did not spell right, alternating series. All right, so let's go ahead and do our error bound. So now I want to use the this guy here. So we know that the sum minus s sub n is equal to the remainder when it is less than or equal to the next term in line, which we want less than or equal to 0.001. So I'm going to take my series here, absolute value of it, and plug in an n plus 1. And then I'm going to make that less than or equal to 1/1000th. If I think about what that's really doing, it's really saying that is 1 over 1000. Now I'm going to use my good algebra skills to go ahead and try to solve for n. So I am going to multiply both sides by n plus 1 squared. So that would give me 1 less than or equal to n plus 1 squared over 1000. And now I'm going to multiply both sides by 1000. So that gives me 1000 less than or equal to n plus 1 squared. I'm going to take the square root of both sides, and I only take the principal square root in this case, less than or equal to n plus 1. Then I'm going to go ahead and subtract the 1 from the other side. So I've got the square root of 1000 minus 1 is less than or equal to n. I'm going to go ahead and put that in my calculator. I'm going to reverse the order a little bit here. I'm going to say n is greater than or equal to. So 1 square root of 1000 minus 1, I get 30.6227. Which I really want n to be a whole number. It can't be a decimal point, so I would round that up. So my n value is 31. So if my n was 31 or greater, I would have an error that was less than 0.001.